Chapter 2. Where in the world is your server? Stand up. Walk to a window if there's one nearby. Look outside. Whatever you see, buildings, trees, a parking lot, someone's backyard, none of that is where your data lives. Your data lives somewhere else entirely, probably somewhere you've never been. That's not a problem. But understanding where makes a surprising number of things click into place. Last chapter, Leo started an AWS account at 11 p.m. and launched a server somewhere. Somewhere being the operative word. He wasn't sure which part of the world he'd chosen, because he hadn't chosen it intentionally. The next morning, Maya noticed the server was in Singapore. Why Singapore, she asked. It was the default, Leo said. Tom looked up from his coffee. How much does it cost to run a server in Singapore when all our customers are on the West Coast? Leo didn't have an answer. Priya already did. It's slower, too. Every request has to travel halfway around the world. This chapter is about fixing that decision and understanding why it matters. The problem with somewhere. When you use AWS, you're not using one data center. You're using a global network of them. AWS has infrastructure in dozens of countries. That's a feature, not just a fact. But it means you have to make a choice. Where do you want your infrastructure to run? The choice matters for 3 reasons. Performance. The closer your servers are to your users, the faster the response. Physics is non-negotiable. Data travels at roughly 2/3 the speed of light through fiber optic cables. A request from Seattle to Singapore takes about 300 milliseconds just in transit, before your application does anything. Compliance. Some industries have laws about where data can be stored. U.S. healthcare data may need to stay within the country. Financial data may need to stay within a specific region. Choosing the wrong region can create legal problems. Disaster resilience. If one location has a power outage, an earthquake, or a network failure, you want your system to survive. Spreading infrastructure across multiple locations is how you protect against local disasters. How AWS organizes its infrastructure. AWS breaks its global infrastructure into 3 nested concepts. Think of them like Russian nesting dolls, from largest to smallest. Regions, availability zones, edge locations. Let's open each one. Regions, the big boxes. A region is a geographic area where AWS has a cluster of data centers. Each region is named after its location. US West 2 is Oregon, US East 1 is Northern Virginia, EU West 1 is Ireland, AP Southeast 1 is Singapore, where Leo's server was hiding. There are over 30 regions worldwide, and AWS adds more regularly. Each region is completely independent. Data in US West 2 stays in US West 2, unless you explicitly move it. This is critical for compliance and for resilience. A major outage in one region doesn't automatically affect others. So we should pick US West 2 for Nimbus? Tom asked. Yes. For a US business targeting West Coast customers, yes. Lower latency, and your users get faster responses. How much more expensive is it than Singapore? Tom added. The pricing varies by region, usually by a few %. The performance and compliance benefit of the right region is worth the small price difference. Availability zones, the real redundancy. Each region is not a single data center. It's a cluster of multiple, physically separate data centers called availability zones, or AZs. Oregon, US West 2, has 4 availability zones: US West 2A, US West 2B, US West 2C, US West 2D. These are real buildings, separated by meaningful distances, far enough apart that a fire, flood, or power outage in one won't affect the others, but close enough that the network between them is extremely fast, single-digit millisecond latency. This is the architecture that makes AWS reliable at a level no single data center can match. Priya leaned forward. So if we run our application across 2 availability zones and one goes down, the other keeps running, Maya finished. Exactly. Leo, who had been listening quietly, I deployed everything in one AZ. Yes, said Priya, we noticed. The concept of spreading your application across multiple AZs, called multi-AZ deployment, is one of the most important resilience patterns in AWS. We go deep on it in Chapter 18. For now, understand that AZs exist specifically to make this possible. Edge locations. Speed everywhere. AZs solve resilience. They don't solve the problem of serving content fast to users in cities far from your main region. Enter edge locations. Edge locations are small, lightweight infrastructure points scattered across over 400 cities worldwide. They're not full data centers. They can't run your application. What they can do is cache content close to your users. Imagine a menu image stored on a server in Virginia. Every time someone in Tokyo wants to see it, the request travels across the Pacific and back. With edge locations, AWS can store a copy of that file in Tokyo and serve it locally, milliseconds instead of hundreds of milliseconds. This is the backbone of CloudFront, AWS's content delivery network. We dig into CloudFront in Chapter 13. For now, edge locations are about speed for static content. Choosing a region, the senior engineer's checklist. When Nimbus expands to serve users in Mexico and Colombia, which happens in Chapter 12, the region decision isn't arbitrary. Here is the thinking. 1. Where are your users? Start here. Pick the region closest to the majority of your users. Latency is the most direct, measurable impact of region choice. 2. Are there compliance requirements? Healthcare, finance, and government workloads often have strict data residency rules. Know your regulatory environment before choosing. 3. Which services do you need? Not every AWS service is available in every region. New services launch in US East 1 first. If you need a specific service, verify your target region supports it. 4. What is the pricing? Regions vary in price. US East 1, Northern Virginia, tends to be cheapest because of its scale and age. South America is slightly more expensive. Check the AWS pricing page before finalizing. 5. Do you need multi-region? For most applications, multiple AZs within one region is sufficient resilience. For critical applications where even a regional outage is unacceptable, you design for multi-region. But that's a significant architectural commitment. Don't do it speculatively. The limitation nobody talks about. Regions are powerful, but they create one important tension. Running in multiple regions is genuinely hard. Data replication between regions has latency. Keeping two regions in sync so that a transaction in region A is instantly visible in region B is one of the hardest problems in distributed systems. AWS provides tools for it, but it costs money and adds operational complexity. Most applications should start with one region, multiple AZs, and expand to multi-region only when they have a clear requirement. Regulatory mandates, contractual SLAs requiring near-zero regional downtime, or a user base genuinely distributed across continents. Premature multi-region architecture is one of the most common and expensive mistakes junior engineers make when they start feeling confident. Tom nodded. So we don't do multi-region just because we can. Not until we need to, Maya said, and we'll know when we need to. How will we know? Leo asked. When your architecture review doc has a requirement that says must survive a regional outage, said Priya. Until then, multi-AZ. Strengths and limitations. Use multi-region and multi-AZ design when your application has users in multiple geographies and latency matters. Your SLA requires 99.99% or higher availability. Regulatory requirements mandate data residency in specific regions. You need disaster recovery with an RTO under 1 hour. The trade-offs are real. Replicating data across regions adds cost. Cross-region data transfer is one of the most underestimated line items on an AWS bill. It also adds operational complexity. Every write that must be consistent across regions adds latency. Most failures that affect real applications are not cross-region catastrophes. They're within-region issues like a misconfigured security group or a botched deployment. Invest in multi-AZ before multi-region. Add multi-region when the business case is clear. Summary: AWS organizes its global infrastructure into regions, availability zones, and edge locations. A region is a geographic cluster of data centers. Each region is isolated. Data stays in the region unless you explicitly move it. Availability zones are physically separate data centers within a region, connected by low-latency networking. Deploying across multiple AZs is the standard way to survive local failures. Edge locations cache content close to users worldwide. They power CloudFront. Choose your region based on user location, compliance requirements, service availability, and price, in that order. Multi-AZ is the standard resilience baseline. Multi-region is for critical workloads with specific documented requirements, not a default starting point. Exam tips: SAA CO3, Domain 1, Task 1.1, Domain 2, Task 2.2. Regions are isolated by default. Data does not replicate between regions unless you configure it. This is important for data sovereignty and compliance scenarios. AZs are the resilience unit for most questions. When the exam asks how to survive a data center failure, the answer involves multiple AZs within one region. Multi-region is for regional outage resilience. If the scenario says must remain operational even if an entire AWS region fails, the answer involves multi-region architecture. Edge locations ache AZs. Edge locations cache content. They cannot run your application server. Don't confuse them with data centers. The exam frequently tests the relationship between compliance and region selection. If a scenario mentions data residency requirements, region choice is part of the answer. In your own words, what is the difference between a region and an availability zone? Why does that distinction matter when designing a resilient web application? Hint: think about the two different types of failure each one protects against. Exercise 2. Exam practice scenario. A U.S. healthcare company must store all patient data within a single AWS region to comply with internal data residency policies. They are designing a new cloud application on the West Coast and want to maximize resilience without moving data to another region. Which configuration best meets their requirements? A. Deploy in US East 1 and use CloudFront edge locations in Oregon to serve content faster. B. Deploy in US West 2, Oregon across multiple availability zones. C. Deploy in multiple regions including US West 2 and US East 1 with cross-region data replication. D. Deploy in US West 2 in a single availability zone to minimize costs. Hint 1. The policy means data must stay in a single region. Which options move data to another region? Hint 2. Among options that keep data in US West 2, which provides the most resilience? Hint 3. Multiple AZs within a single region provides resilience without crossing region boundaries. Answer: B. Explanation: US West 2 keeps all data in a single region, satisfying the policy requirement. Deploying across multiple AZs within that region protects against data center failures without moving data to another region. This is the correct balance of compliance and resilience. Why not A? CloudFront caches content at edge locations globally. Data would physically leave US West 2, violating the residency policy. Why not C? Replicating to US East 1 moves patient data to the East Coast, directly violating the single region requirement. Why not D? A single AZ has no resilience. If that AZ experiences an outage, the application fails completely. SAA CO3 Domain 1, Task 1.1. Exercise 2. Exam practice scenario. A U.S. healthcare company must store all patient data within a single region zone. Currently, everything runs in Mexico and Colombia. The team is debating, should they add a U.S. East 1 second region or stay single region with multiple AZs? What questions would you ask before deciding? What are the main costs and risks of adding a second region? What is the main cost of not adding one? There is no single correct answer. Practice the multi-region trade-off reasoning. Post-credit scene. Leo fixed the Singapore problem. Nimbus moved to US West 2. The latency dropped. Tom's one follow-up question, did that change our bill? Was answered with a slightly higher number, which he accepted with visible reluctance. That lasted 2 days before the next problem. Leo came to the stand-up with the expression Maya had learned to recognize. The look of someone who'd done something they couldn't undo. So, he said carefully, I set up the server, and I needed a way to log in, so I created a username. And, Priya asked, admin. Silence. And the password? A longer silence. Admin123. Priya stood up. In the next chapter, how Nimbus controls who can touch what, and what happens when they get it wrong.